All right, welcome to Trino Engineering at Microsoft. So we're going to talk about some of the interesting things we've been doing, changing in Trino as we use Trino and make Trino available to teams internally and externally at Microsoft. So first, I'm going to introduce myself. My name is George Fisher. I've been working on big data systems for a long time, built big data platform for Windows, built big data platform for shipping Edge. So I was a data owner for a long time, data engineer, and then moving to the Azure team where we are now shipping Trino. So I've been using Trino for individual deployments, and now we're shipping it as a service.
Hi, my name is Ishan Patwa. I also work in the Trino team at Azure, Azure Data. Prior to this, I was building real-time analytics platform for Edge and Windows, and currently I'm working on Trino at Microsoft.
All right, so I thought I'd give you a little bit of a team's background to us, a little team story. So we've been building, as I mentioned, we've been deploying Trino and Presto for a while. And originally, back about 3 or 4 years ago, what it was we would have the Trino Presto Helm chart, and we would sit down in a room for 3 to 4 hours with internal team, and they would say, in a conference room, we would just deploy, config. It was a huge mess and somewhat stressful. So now, to resolve, because of the internal interest and external interest in Trino, we formed a team in Azure Data to ship Trino as a service. So now it ships through Azure Resource Provider. We have which then, so the Azure APIs or Azure Portal, you can create. It deploys AKS, and on the AKS, we have Trino controllers, which then manage the Trino deployment and then create the Trino pods as appropriate. All right, so I already mentioned it was basically platform as a service. Big things we have to do was AAD, Microsoft Entra ID integration, so managed identities, used everywhere, user identities, role-based access, log analytics, and basically, and private cluster deployment behind the VNet, behind Azure VNet. But, and I'm not going to go through all this in huge detail. These are some of the things we've did, but I wanted to call out, so what happened is, when we used to deploy individual clusters, it was a story of there was a lot of control. So there would be a custom UI for that team, and we usually deploy Redash. Now people use whatever client they want, and it has to be, we have to have integrated with Microsoft clients. So it's a more integrated experience. Some of the more recent demands is have a C# client, of course, because we're Microsoft, and one of the things people are using this for is integrating into their copilots. And what they're doing is they're building systems that have a bunch of metadata on their tables. People write descriptions, and then they generate queries out of that. And that uses our ADO.NET driver. In the future, we're really interested in Arrow or Flight SQL, because a lot of our internal systems are switching over to using these as formats and protocols. Yep. All right, well, we're going to talk about some of the details today, some of the interesting stuff we've done. So first, we're going to talk about result caching, responsiveness, and then what if your data is frequently changing and mutating? We have something called the Sharded SQL connector, which we're going to go into detail with. And then finally, we're going to get onto the problem of people coming to us saying, my query is slow, but if we have a very large number of clusters, how can people manage those themselves without us having to become consultants? All right, so first we're going to talk about result caching. So this is quite a simple idea. Basically, the idea is it stores the query result. So when you run a query, the result is readily available if it has been previously cached. So the best way we thought to introduce this is to go through a bunch of our configurations to enable this. And of course, time to live is obviously a basic requirement for a cache. But I wanted to mention forced refresh, because when we were in Windows team and we were running Windows data for ship rooms, so shipping windows, what would happen is people would come to us about 10, 20 minutes before the ship room meeting and say, the data is late, the data is wrong. We need to refresh the cache. And eventually they got to the point where they basically had a small team whose job it was just to refresh caches. So having forced refresh as a control is really important. And then excluded entities is a really important thing as well, to be able to exclude information schema by default, so your schema is up to date, but also to be able to exclude specific tables and catalogs by prefix. All right, so let's just show this in operation. And I'm going to press escape, and that should make it a split screen mode. Good, good, good. And I'm going to shift this up slightly so I have access to, there we go. There we go. So what I'm going to do here is I have a report here, and this has the forced refresh session property enabled. And I'm going to say actually one thing about session properties is that we actually had to build a multi-query support for session properties because we so often use session properties and so many clients don't support it, although Power BI does. So you can actually have a semicolon and run a query that has set session as well in there. So what I'm going to do is I'm going to just refresh some of this data here. This is basically a scaled version of the New York City yellow taxi data. And what we're doing is now is we're hitting the data directly. So we're running the query. And we're going to see these directly execute. So of course, because we're directly executing against the data, we're going to see a very large number of splits executing here. All right, so those will, I'm going to run through. OK, so coming back to here, we'll give it a couple of seconds. So this is a relatively large data set. So we'll get that to come through. So once it comes back. All right, that should be up to date. Perfect, OK. So that is scale factor 14. So what I'm going to do now is I'm going to go over to this other report, which actually has the caching enabled. So I'm now going to enter the same value, and I'm going to apply filter here to the query, and I'm going to go over to Trino here. And what I want to show you here specifically is the execute statements here. And what you're going to see is that they have two splits. So that is right here. And that means that is hitting the cache, and it is coming back directly. So if we go back to that report, it is completely refreshed. So let's get back to the presentation. Okay. So some details about this. So what is the flow? Is query cacheable? Is not querying information schema or excluded tables? And make sure it is a select or execute query. A cache key is the physical plan. So this is important because you want it to be invariant to text. You want to be able to add comments to your query. You want to be able to modify capitalization, spacing, and everything like that. So you actually have the physical plan as the key. So if the query is already cached, then we update the plan. So we replace the root stage with a new stage that has cache output statistics and create a new table scan stage instead of the existing query. All right, so this is actually a read-through cache. So what we mean by read-through cache is the data result is cached first and then served out to the client. So what's happening is as soon as you start executing a query, we rate and poll the Exchange client and write the pages as they come back to the attached volume. This is not just a read-through cache, though. It is read ahead. So what happens is our poller is actually reading. It's an eager reader. It's actually reading every page as soon as it's available. And the benefit here is the resources get returned to the cluster as the query completes. So we're freeing up resources from the Trino cluster. And then the reading side is quite straightforward. Basically, if it's cached, if we're on the current page, read the current page from memory. If we're behind, read from store attached volume. And if we're not, we read from we wait on the Exchange data source. Oh, and I have a little demo here, which I'm going to get started. So what this is so in this situation, I'm running a query. This query is running against storage directly. You can see that because it has a large number of splits. And this is against an iceberg table here. And then I'm going to run the query again. And this has got cache enabled, so the query result will come back right away. Okay. Now, what we're going to do is we're going to do a modification to the iceberg table. So what I'm going to do is I'm going to insert one row into the iceberg table. And what this will do is it's going to modify the iceberg metadata. And as our cache key is the physical plan, this now means the plan will have changed. So when I run the query again, without having to do anything, it's going to no longer read from cache. It's now going to read directly from the storage and update the cache as we go. Oh, improvements and future work. Cache should not be implemented like this. This was a bit of a hack. We did this because it was faster. We discussed having planned fragment caching, building an operator to do that. And we thought, no, that's too much work because response caching is what we need right away. So we're very excited about that being discussed as part of the open source Trino. That's excellent. But what if the data is frequently changing? In a case where your data is changing so frequently, if you cache the results, you're just not going to be up to date. So we built a new connector which helps solve this problem, and Ishan is going to talk us through that.
Okay, thank you. All right, so I'm going to talk about the Sharded SQL connector, but before going into details, I want to cover a little bit about what this connector is and what it does. So just like any other connector, and this lets you create abstractions over your data sources. In this case, Sharded SQL Server connector allows you to query multiple SQL servers. So what that means is when you have a table in this connector, it's actually a representation of data spread across multiple SQL servers and multiple nodes. Some of the reasons why we did this connector or why it's advantageous is because we wanted to leverage the leaf node acceleration capabilities provided by SQL Server. And by that, I mean the ability for us to push down predicates, push down aggregates down to the data source, and offload some of the compute out of the Trino cluster. This connector is really helpful in performance critical scenarios, especially where you want to have control over the performance profile of your reports or your dashboards. And really, if you want to remove the unpredictability that sometimes comes with object store. One of the side effects of that unpredictability is they're hard to diagnose, they're hard to debug and predict. But with multiple SQL servers, it really gives you complete control over your data source as well. So any performance issues you can log into your SQL server, profile it, and figure out where the bottlenecks are. SQL servers are good at joins. So naturally, if you have data laid out across multiple SQL servers, especially in the case of those classical star schema data sets, Trino can push down the joins down to the connector level, down to the data source, which really saves us a lot of compute for getting rows back into Trino cluster, performing the expensive join operation in those cluster. And lastly, one of the advantages of how we model this connector is the ability for the users to define a two-dimensional layout of the data across multiple servers. And I'll talk more about that in the next few slides, what that means. All right. Oh, before going deeper into the connector itself and the data model that I mentioned, when I was preparing these slides, I ran queries on the same data sets from Iceberg connector and from the Sharded SQL connector. And I just wanted to share it here because the results look very promising. On the left of the slide, you'll see that the result came back from Sharded SQL connector. That's because we pushed down the aggregates down to the SQL server themselves. So query comes back in less than a second. The same query pulls a lot of data out of object store, does the aggregation in the cluster, and of course, it's about 9 seconds. Just to demonstrate some of the points that I made in the previous slides on how this connector can be leveraged. All right. So diving a little bit deep into what the data model for this connector looks like, it's very beneficial to compare it with HDFS-based connectors that we have. So I'm going to take an example of Iceberg here. One of the ways that you can lay out your data in Iceberg is you can partition your data, and then you can bucket them across partitions. It's really represented in a very simple way here, where you can say, hey, I'm partitioning by year, and the bucket for my Iceberg table will be month with that bucket function specified in the slides. Similar to how we how we lay out the data in object store in Iceberg table, we can do pretty much the same thing in the Sharded SQL connector, where we can model the data the same way. And the way it's done here is through a manifest. The table takes a reference of a manifest. In this case, a partition year is the manifest name. And a simple JSON representation of that manifest looks like this. Some of the important things to call out here is that similar to how we have Iceberg partitioning and bucketing, you can specify partition and bucket keys in Sharded SQL connector. In this example, I'm again partitioning by year and bucketing by month. And you can define a map of partitions which describe how the data is laid out across multiple servers. So in this example, I would say my partition for year 2009, buckets 1 to 12 live in shard 1 and shard 2. There are multiple reasons we model the data for this connector this way. And I'll go into those in detail in the next few slides. But one of the things that I wanted to call out is this also gives us ability to this gives users a lot of flexibility to scale partitions independently, because in most of the cases where you have large amounts of data, it's unavoidable to have skew. And in those cases, you really want your compute to reflect that, or your compute resources to be serving more of the skewed partitions, and you need less compute resources to serve smaller partitions. And this allows users the ability to do that or perform that, or model their data in multiple servers. All right, so let's dive into a little bit into some of the features that we have added to this connector. The very first thing I want to call out is Sharded SQL connector is really built on top of the base JDBC module, which is used by a lot of JDBC-based connectors right now. So a lot of features that were implemented for the base modules and which apply to multiple SQL Server scenarios are just inherited into this connector out of the box. On top of those, there are a few features that we added, which I'm going to talk about next. The very first one being the ability to prune partitions. Now, in the scenarios where I'm querying multiple servers, I really don't want all of my queries to fan out in all of the SQL servers. That's not an efficient use of compute. So that's where the manifest kicks in. The connector is intelligent enough to prune the SQL servers which don't serve my query. A very good example of this is a simple query that I have here. On the left, I'm running a simple count query against this connector, and you'll see that the number of rows I get back is 2. That's because this table, a yellow 2, is distributed across 2 SQL servers. On the right, I run the same query, but with a predicate added to the query, which is rate code ID equals to 1. This predicate, the connector understands this predicate and prunes the partitions. In our case, prunes out one SQL server, which does not have any data for rate code ID once. So the query really fans out to one SQL server. In this specific scenario, rate code ID was one of the partitioning key for my tables. This is really useful in saving some unnecessary calls going out to SQL servers which don't really serve any data. One of the features that I also talked about in my initial slides was collocated join pushdown. So here's just one example of Sharded SQL connector pushing down the join down to the SQL server. On the query that I have on my screen, to the left, we have a query plan that basically scans data from 2 sources, joins them together in the cluster, and then returns the result back to the client. On the right, I have the same query with a different plan in which the connector pushed down the join down to data source, and all we got back was the rows coming back from the SQL server, which was then pushed upstream to the clients. The difference in these 2 query plans is really on how the table that I'm querying, how my tables are partitioned, are laid out across multiple SQL servers. The plan on the left is for the tables which are evenly spread across multiple SQL servers, so the connector cannot push down join because we'll just get incorrect rows back. On the right, the connector understands that the table is laid out by region key, so it decides that it can push down the join to the SQL Server node, and it does that, and that's how we end up having this plan where we don't have to perform the join in Trino. So this is just an example of how connector is smart enough to push down joins and push down compute-heavy operations whenever it can. One of the last features that I want to talk about that we added is the ability of to do partial aggregate pushdown. I've already mentioned this before in passing, where I said that Trino can push down aggregations down to SQL Server. But this really doesn't apply to all aggregate functions, only the one that can be decomposed and then merged back together. And we added this functionality for this connector, where we basically looked at the query, look at the aggregations in the query, and the connector decides, hey, can I push it down or not? For example, in this query, the count query that I have, you'll see that the number of rows coming back is 2, not 1. If it was a case of SQL Server connector, it would have been just 1. The count would have been pushed down. The reason it's 2 is because, again, the table is laid out in 2 different SQL servers, and Trino is pushing down the aggregates. And that's reflected in the query plan to the right, where I have a partial aggregation stage, and then I have a final aggregation stage. That really covers some of the features that I wanted to mention for the Sharded SQL connectors. I wanted to spend a little bit of time talking about some of the challenges that we ran into. And one of the challenges was clearly the aggregate pushdown capability. Natively, Trino doesn't push down partial aggregates in table scans. So that's something that we had to build ourselves. So after looking at how Trino does all the optimizations for different connectors, or just in general for connectors, what we decided to do was really solve this problem by extending the metadata API for connectors, where the optimizer can ask the connector, say, hey, do you support partial aggregate pushdown? And if the connector responds, yes, I can, we added an optimizer rule that basically understands the result of that pushdown operation, and then rewrites the query plan based on what aggregations were included in the query. And that really helped us work around the problem of aggregates not being pushed down to the SQL Server level. We do have a lot of work planned in future for this connector. Support for replica sets, support for redundancy, just to improve the reliability and performances for Sharded SQL connector. And I think that covers pretty much it. I did talk a lot about performances. So I'm going to hand it back to George, because there are cases where we have some other connectors that customers are using. Performance really is not what they expect, and they want us. They usually come to us to ask for our help as to, hey, why is my query slow? Why is it not working? So I'll hand it over back to George to talk about scan stats.
All right. So yes, so one of the challenges we've had is, what if a query is not performant? Now, in the old days, we would go in and we'd actually look at this query and look at the plan and look at the statistics and try to understand it. But what we needed to do was put some of this into the hands of the users, or the cluster owners. So we're going to talk a little bit about cluster operations, and we'll focus on a specific feature here. So most important is we have to ensure the security and privacy of clusters. So when a cluster is created, that cluster is owned by that team and often contains extremely confidential data, and we will have no access to that cluster. So from our perspective, from operations standpoint, we have access to the logs associated with that cluster, and we have some limited operations to perform direct commands at the user's request on that as part of a support ticket. But a lot of this has to be customer facing, and if the customer can solve their own problems, and with Trino, it's often really, as people get into it, they really get joyful about debugging queries, and I like to see that, and we like to encourage that, of course, because we don't want that to come back to us, and we're not consultants, although I do enjoy that part. So for self-serve cluster, we owner-facing. First of all, we basically have the Trino logs. We have query logger, which allows you to, which logs the query split operator to an auditable Hive table in Azure, so you can actually just query what the history was and look at what people are doing with the cluster. But the thing I'm going to talk about right now is scan stats. So scan stats is all about connector read performance. So basically, typically this was a Hive, Iceberg, or Delta, or Hudi. where the reads are slow, and what we want to do is diagnose what the problem is and give all the tools to that user. So what I'm going to do is I'm going to demonstrate, rather than describing this, I'm going to actually demonstrate what this looks like. And what we have done is, if I go back here, actually I'm showing you already, but here we have an extra tab on Trino UI, which is scan stats here. And if you click on this, and you can go to a page that looks like this. And what this does is it has a summary of absolutely everything you would need to know, or at least I would need to know. Well, I'll tell you about it in a second. But we'll go down first, because the most beautiful part is this part here, which basically shows every single split. Now, in this case, we're actually showing the top 10 splits per worker with slowest execute time. And what I can actually do is I can actually click on this, and you can see what file it was reading, how long it took to read that file, what range it read, and all details. Okay? And then to contextualize this, I can actually select this, and I can see the first, and I can see the last reads there as well, so that shows what's happening. And in fact, in this query, which I ran earlier, we can just see if there is anything outlying, and there isn't. This was actually fairly good. I actually have one from earlier, which has a bunch of red from this worker here, so that is problematic. As I was saying, there's a bunch of statistics here. We have a step-by-step process you can go through in our documentation to read to understand how to interpret this. But if you copied pasted this to support, that would be also something that could be understood immediately. And there's a lot of iterations over time. This is enabled to figure out what statistics there. There is a session property which enables this. The collection, how it works is it feeds split statistics into the query JSON. It's extremely lightweight. It almost has no performance impact at all. So I can run this on benchmarks, which is just wonderful. All right, that's all we have. We have some time for a Q&A, I believe. Probably have like 3 or 4 minutes.
Yes, we have a couple of minutes for questions. Do we have any questions in the room?
Hey guys, the sharding connector is super cool. I was curious if you found that the way that people have sort of naturally set up sharding on existing installations is kind of already good for reading through Trino and this sort of delegating method, or if this is sort of different from the way sharding is naturally done, and if you've sort of had to retrain people to shard differently.
So there's some context to this. When before working on Trino, we were running Sharded SQL servers on Windows Data Platform, and we had our own query engine that queried those servers. And back then, one of the ways that people modeled their data on those servers was very reflective of what I talked about. So that's where the inspiration came from, because we ran into all the problems of hot partitions. We had data skews that we had to deal with. We had to re-ingest data into more SQL servers. Expanding the cluster was an issue. So all of those things we ran into in our previous experiences that really translated into this connector. Hope that answers your question. Yeah.
So this is great. It's great to see all the things you've been working on. So caching is something that we've been talking about for a while. So we should sync up on that. I was wondering, where's the PR for this?
It's all about us having the time to do that, because there's always one more thing we want to do.
Is also invested in asking, where's the PR for this?
You mentioned partial aggregation pushdown.
Yes.
I have a PR where we're going to replace partial aggregations by decomposing aggregations into just more aggregations. So it'll be more universal what you're doing, and you'll be able to get rid of that patch. Just talk to me afterwards so I can go through it.
Awesome. Thank you.
That's also a general call out. We are meeting like people like George and Ishan and others. We are meeting for like the deep discussion on these kind of contributions tomorrow. So if anyone is interested in that, please let me know. And also, we'll dive into how to get those PRs going. And that's it for this session. Thank you again.